Section 11.7, Avogadro's law. We've looked at the relationship between volume and pressure and volume and temperature, and now we're going to look at the relationship between volume and number of moles. In all of our previous examples, the amount of gas has stayed the same, but what if that changes? So an experiment can be done like this, where you're changing the number of moles of gas. As that increases, we measure the volume and we find that the volume also increases. And this makes sense. If you put more stuff in, it should take up more space, right? The volume increases linearly, which means it's a direct proportion. If you double the amount of gas, you double the volume. And this was first formally stated by Avogadro back around 1800-ish, somewhere in there. He was born when our country was born. That's kind of cool. So this assumes constant temperature and pressure, and so we have what's called Avogadro's law. The volume of a gas and the amount of gas in moles are directly proportional. And where have we heard Avogadro's name before? Avogadro's number, right? The number of pieces or items in a mole. And the concept of a mole came out of his work, because this is what helped them to understand that it has to do with the particles and not with the mass of something. The volume is not proportional to the mass of the gas. It's proportional to the number of particles, and so that's important. Here's a picture of a little boy. It's kind of obvious, but you blow into a balloon, you're pushing air into the balloon and you increase its volume. So let's do an example. And I was going to fix this. There's no statement in the slides of what Avogadro's law is, so let's write that down for you. Let's choose this color. It kind of looks like chalk. It would be V1 over N1, equals V2 over N2. So that's Avogadro's law. So here's an example. A 4.8 liter sample of helium gas contains 0.22 moles of helium. How many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? So we're going to need a table. So we'll have a couple of rows here. We'll have condition 1 and condition 2, and we'll go through the problem and put numbers in here. 4.8 liter sample, so that's a number, 4.8 liters. Liter is a unit of volume, right? It doesn't say the volume is 4.8 liters, but we should understand that by knowing what liter measures. It measures volume. 4.8 liter sample has 0.22 moles. 0.22 moles. And that's given the symbol lowercase n. N is number of moles. Amount of gas in moles. How many additional moles must be added to obtain a volume of 6.4? So they're giving us the final volume is 6.4 liters. So we have a table with one blank square or rectangle. So that's N2. Now we've talked about 3 different equations, and sometimes students have how do I know which equation to use? Well, what variables do you have? You've got volume and number of moles, then use the equation that has V and N, and that's the one written at the top there. So we've got V1 over N1 equals V2 over N2. And we're solving for N2. What should we do first? Cross multiply. You need to get rid of those fractions. Unless you're good with algebra, then you're on your own, but you'll be fine. So we're going to cross multiply. We'll end up with V1 times N2 is equal to N1 times V2. So I took these two guys and multiplied them together, and I took these two guys, and that's called cross multiplying, and that's how you can get rid of fractions. So I'm going to highlight this in red again. So we're looking for N2. Now we can rearrange the equation. It's less dangerous. We've declawed the tiger. So I'm going to divide by V1 on this side because I don't want V1 next to N2. I want N2 all by itself. If I do that on one side, I have to do it on the other side. V1 over V1 equals 1. Anything divided by itself equals 1. And so that's how we move something to the other side. If you need help with that, please ask me after class, because I can help explain that to you, and it's important for you to know how to do this. So N2 equals N1 V1 over, see, I made a mistake, N1 V2. Really important to get those subscripts correct. Now I look at the table, and N1 was 0.22 moles. And V2 was 6.4 liters. V1 is 4.8 liters. And when we look at our units, liters cancel liters. And we do some math here. Calculator, 0.22 times 6.4 divided by 4.8. And this should have two significant figures, so 0.299 moles. Any questions so far? Is this the answer to the question? How many additional moles of helium must be added to the sample to obtain a volume of 6.4? What did we find? We found the total number of moles in the 6.4 liter sample, which we need to find, but that's not the answer. Okay, so this is an example of a question that has a little twist in it. Okay, and there can be some of these on an exam, just, to warn you. It's not all going to be absolutely straightforward. So there's a combination of two ideas here. Solving for a variable in a gas law problem, but then also understanding what is the question asking us. So it's a 4.8 liter sample, and it has 0.22 moles. We want to put some helium into it. Let's, maybe it's a balloon. We want to put some helium into it to make the volume larger, so it's 6.4 liters. They're not asking what's the total number of moles. They're asking how much do you have to add. So how do we find that out? We subtract. This is the total number of moles in that new sample, and so we subtract what we originally started with. Let's do that over here, maybe in a different color. So we're going to take 0.29 is what we end up with, but we started with 0.22, and so that equals 0.07 moles. To take that 4.8 liter sample of helium and make it be 6.4 liters, we have to add 0.07 moles. Okay? On a multiple choice test, there would probably be an answer that says 0.29 moles, because we know that a common mistake would be to solve for N2 and feel like you're done, right? Just because you find a number that's one of the choices does not mean you did it correctly. Any questions?